Okay, so this is going to be an overview of the chapter. So as you can see on my screen, I literally typed this up, what I'm going to say. So did this for two reasons. One, so that you can have this not only to hear, but to see and read at your own pace if you'd like to. And so I'd just like to point out that this is really an overview. I'm trying to avoid the jargon and the minute details of it, just because I want you just to understand conceptually and the big picture. And then through the rest of the videos and the rest of the chapter, you can fill in the gaps. You can fine-tune the specific language, because there are a lot of details that just little wording, that if you get incorrect or you switch it up, it can be considered wrong and people can get really upset about it. So I'm just trying to give you this information ahead of time. So this chapter, it's not that it's hard, but some of the concepts of it, the basic, are a little bit difficult. It can be really confusing. So there was a recent study that found that most intro, I'm reading this from my screen, to stats textbook in the field of psychology specifically, that discuss statistical significance, define or explain it incorrectly. So that concepts of p-values. So it can be really confusing. There's a video out there, I should find it, that asks people explain what a p-value is, and not just people, but people who teach stats, and they really struggle to articulate and explain it. So it's not easy. It's not an easy concept, and one reason why it's not easy is because it's not really intuitive. It's weird. Like the way you say things and word things seem backwards. Like we test the null hypothesis, which says that there's no difference. So why are we testing that? I mean, really, sometimes that's not what we really want to know. So there's things that are just confusing. So I'm going to do my best to try to just explain things in a simple way. I'm hoping that I don't say something too incorrect, but sometimes it helps just to understand the big picture. So that's what I'm saying, is just to get the big picture, the concepts of it, and then later throughout the other videos we'll fine-tune the language and the concepts. So right now, purpose of this video, big picture, so you have the understanding of it. So as we go forward, the other videos are easier to kind of fill in the gaps. So let's talk about this. So let's have an example. Let's assume we're looking at cell phone battery life. So let's say we work for Samsung and we want to develop a new battery that lasts longer so that we can advertise a new cell phone with a longer lasting battery, because I think that's what a lot of us want. I know that's why I had to buy my last cell phone. So for now, let's assume that the old battery lasts 8 hours and we want to test our new battery to see if it lasts longer than 8 hours. If it does, we can safely advertise that our new cell phone has a longer lasting battery, which should help increase our sales. So we developed a new battery, and now we have to get a sample to test to see how long the battery lasts. So to do this, we randomly select 50 phones, and we do some type of study where we have them used and we record how long they last. So how long does the battery last? Remember, we're using 50 because it's a large enough sample to create a normal sampling distribution, which helps us calculate our probabilities. So for our random sample, let's say that one of our battery lasts 8 hours and 45 minutes, another lasts 7 hours and 51 minutes, and so on. Of all the 50 batteries, we calculate the average, and let's say we find it to be 8 hours and 28 minutes. So in your opinion, I'm asking you, I want you to think about this. What do you think? Would you conclude that this new battery that we created, right, is better, meaning that it lasts longer than the old battery? So remember, the old battery lasts 8 hours, but now we created a new battery, and we randomly tested 50 batteries, and we found that the average was 8 hours and 29 minutes. So 8.5 hours basically. It's basically lasting 30 minutes longer on average than the old battery. So what do you think? Right? And there's no right or wrong answer to this question right now. What do you think? What would you say? What's your opinion? So you can kind of think about that in terms of, is it longer? Would you feel safe and comfortable advertising that we have a new phone, the battery lasts longer? What do you think? What if we found that the average is 8 hours and 10 minutes? Would that change your answer? What about 9 hours? Right? So technically, let's say that both sample averages, 8 hours and 10 minutes and 8 hours and 29 minutes, both of them, right, are greater than 8 hours, the life of the old battery. So you really wouldn't be wrong in saying that those numbers are greater, right? 8 hours and 10 minutes is longer than 8 hours, right? 8 hours and 29 minutes is longer than 8 hours, but I mean, again, how comfortable would you feel advertising that? Again, think about this, that these are random samples. There's error in our point estimates. Remember, a sample, right, that average is a point estimate of a true population parameter, like the average battery life of all of the new phones, right? So if we collect a different random sample, we'd get a different average, right? If we had a different sample size, we'd get a different average. So we have to take that information to determining if our average, really, are they greater than 8 hours, right? So basically the point that I'm trying to make is that there's what's called subjectivity, right? Bias, our opinions, our thoughts in our conclusions. So some people might say 8 hours and 10 minutes is longer than 8 hours, whereas other people would say, no, you can't really say that. I wouldn't feel comfortable saying and advertising to consumers that the battery lasts longer. However, I might feel safe saying 8 hours and 29 minutes is longer, right? It's an extra half hour. Nope, that's my dog. Sorry about that. Scout! Sorry, can't do much about that. So this is where inferential statistics and the concept of statistical significance comes into play. So remember in Chapter 8, we learned how to do this. Or at least the concepts leading up into this. So we can basically, in this chapter, what we do is we learn how to determine objectively, right, with less subjectivity, whether or not we can say 8 hours and 10 minutes or 8 hours and 29 minutes is actually longer than 8 hours or not. So again, originally we kind of had this question, is 8 hours and 29 minutes or 8 hours and 10 minutes, is that actually longer than 8 hours, right? If we were to ask everyone that, people would have different opinions. Some people would say it's longer, no matter what, those numbers are greater than 8 hours, we can safely advertise that. Other people would be like, well, 10 minutes, half hour doesn't really make that much of a difference, or it does. So what we want to do with hypothesis testing, inferential statistics, is we want to take that subjectivity out, and we want to use statistics, math, an approach, a process that other people would be able to replicate and come to the same conclusion. So that's the whole idea of these concepts of the null hypothesis significance testing, the process, having p-values, objective numbers, cutoff points, to be able to come to conclusions. So for instance, if we go through the process of hypothesis testing and checking for statistical significance, which is partly what this chapter is about, we could conclude, right, yes, 8 hours and 29 minutes is more than 8 hours, and therefore we can justify advertising that this battery does last longer. Or we might find that no, through this process, no, we do not have support to say that. Another question you might have is, okay, well, maybe 8 hours and 29 minutes is statistically significant, meaning yes, objectively there is an effect, it is longer, but is it really enough to make an impact on people's lives? So think of yourself personally. Would you pay more money, or would you pay for a phone to upgrade to get an extra 29 minutes on average of battery life on your phone? What if the 8 hours and 10 minutes was statistically significant? Would you pay more for an extra 10 minutes of battery life? Me, I wouldn't pay for that. That wouldn't make much of an effect for me personally. So we have another issue. It's called the issue of practical significance. So sometimes we find that something is statistically significant. Yes, right. There is some type of effect, or there is some type of difference. Sorry, I lost where I was reading. that is, we use, right, inferential statistics to determine objective answer and determining, right, if two things are different, like I just said. But that doesn't always mean that that numerical difference that we find translates to making a practical and useful difference. So there are measures of practical significance. There's measures of what are called effect sizes. Effect sizes come in sizes: small, medium, and large. So if you have a large effect, that basically says that, yeah, the effect that you found, that significance, is pretty influential, does have an impact on what you're looking at. Our textbook does not teach it. I think one reason is reporting effect size is not that common in business. It's starting to gain traction. It's a big thing in psychology. It's required. It's expected to be reported with results, so you find it more in psych books. We're not going to touch on it, but I do want you to be aware of it. So again, in summary, we use inferential statistics and this whole concept of hypothesis testing to determine if something is statistically significant. If something is statistically significant, basically we can say, yeah, there's a difference. There's an effect. We found something that's meaningful. The process allows us to have a more objective conclusion using data and statistics rather than relying on our subjective thoughts and idea, right? Is 8 hours and 29 minutes more than 8 hours? Right? I mean, that's debatable. But if we use this whole process of what this chapter is about, we can more objectively say yes or no. There is some type of fact that, right, that battery does last longer or it doesn't. So the process allows us to test a question that we have and increase the likelihood that if someone else had our data and the same information, that we'd all come to a similar conclusion. So it takes the subjectivity out and it makes our approach more objective. So that's really the idea of hypothesis testing, p-value, statistical significance, right? Is it helps us test some type of statement that we have about our population, right? And then evaluate that statement in terms of, do we have support for that statement or not? So in the next video, I'm going to talk about this idea of p-value, statistical significance, in a little bit more detail. So watch that video too, and hopefully my dog doesn't bark in that video.